Imagine you are building this, planetary scale digital factory. Welcome to today's deep dive, where we actually have the blueprint for how massive enterprises process, store, and really trust petabytes of data without managing a single server. We're looking at the architecture of Google Cloud's analytics and data services.
Right, and the core shift here is really moving away from manual infrastructure. It's about designing a system that automatically scales its compute power, whether you are analyzing like a few thousand rows or a massive global stream of real-time events.
Okay, let's unpack this. We have to start where the data actually lives, right?
Yeah.
When we talk about BigQuery, I like to think of it less like a traditional static library and more like almost a gig economy for data processing.
Oh, I like that analogy.
Right, because you don't own the workforce. You just put out a request, and thousands of workers instantly assemble, find your data across petabytes, and then they just vanish the second the job is done.
Exactly. That's the power of decoupling storage from compute. You aren't paying to keep servers running 24/7. You really just pay for the query itself.
But I mean, if I put all my enterprise data into Google's ecosystem to get that performance, aren't I just trapping myself? Like, what about vendor lock-in?
Well, what's fascinating here is how the lakehouse architecture solves that exact problem. A lakehouse bridges your structured data warehouses and raw data lakes using open table formats like Apache Iceberg.
Okay.
Think of Iceberg as this universal translation layer sitting right on your cloud storage.
So the data isn't locked in some proprietary vault.
Right, because the storage format is open, external processing engines, like Spark or Presto, they can read that data directly. You get the governance and performance of BigQuery, but you never have to duplicate or export your data just to use a non-Google analytical tool.
Makes sense. So we've solved the storage trap with open formats. But a massive warehouse is essentially a data graveyard if the information takes days to arrive.
Stale data isn't helpful to anyone.
Yeah, exactly. How do we get live events streaming in without crashing the system?
You need a robust ingestion layer, which is where PubSub comes in. It acts as a massive shock absorber. If a mobile app suddenly spikes and sends millions of events per second globally, PubSub just catches and queues them up.
So it's kind of like the central nervous system handling the shock.
Right, exactly, without the system going offline.
And then those queued events need to be processed. That's Dataflow, the automated assembly line. But wait, historically, processing historical batch data and live streams required two entirely different code bases, right?
Precisely. You essentially had to build two completely separate pipelines. But if we connect this to the bigger picture, Dataflow changes that by abstracting the infrastructure entirely.
Oh, really? How?
Well, it treats a batch of historical data simply as a stream that has a defined beginning and end. Because of that underlying logic, developers can write the pipeline code just once, and it handles both real-time streams and static batches perfectly.
Wow. Okay. So the data's flowing instantly, the pipelines are unified. But here's where it gets really interesting. Once that data is moving at lightning speed, how do you ensure the business, and increasingly generative AI, isn't completely misinterpreting it? Like, why do we need a semantic framework just to read our own data?
This raises an important question because that's the biggest risk. Fast data without context is actively misleading. Generative AI models, for instance, don't inherently know the difference between revenue in a marketing spreadsheet versus revenue in an accounting database.
Right, they're completely different numbers.
Exactly. Without a semantic framework mapping out that business logic, AI will just hallucinate.
The classic fragmented spreadsheet problem, but on a petabyte scale.
You hit the nail on the head. This is why Google integrates tools like knowledge catalogs and Looker. Looker uses version-controlled, Git-integrated metric governance. Basically, a data team defines the exact mathematical formula for a metric like revenue just once, right in the code.
And that definition becomes the strict rule book universally applied across the company, as opposed to, like, Looker Studio, which is more for ad hoc, drag-and-drop dashboarding.
Right. By centralizing the business logic, you ensure that a human executive and an AI agent are pulling from the exact same single source of truth.
Okay, so when you zoom out, this architectural shift is massive.
Yeah.
So what does this all mean? Whether you are using Google's healthcare API to standardize and process clinical data under strict HIPAA compliance, or, tapping into Earth Engine to run planetary-scale climate risk assessments using satellite imagery, it all comes down to a fundamental trade.
Yeah, you are trading server management for instant insights.
Exactly.
You're letting the cloud handle the heavy lifting of the infrastructure, the scaling, and the translation, so your team can focus entirely on extracting value from the data itself.
Which leaves me with this final thought for you to ponder. If you're building this planetary-scale digital factory, and the system can automatically handle petabyte-scale storage, open-format interoperability, and semantic AI governance entirely on their own, what happens to the traditional database administrator? Are they becoming completely obsolete, or simply evolving into something entirely new?